Good evening, my YouTube viewers. It is Crystal here. I'm here to make another video for you. If you'll notice that the video that I made this morning, I gave you instructions on how to calculate the autocorrelation function, the correlation coefficient. In this video, I'm going to do a random walk. And when we do the random walk, we're still going to use the autocorrelation coefficient or the ACF autocorrelation function because that's going to be crucial to this random walk. So a random walk is part of a Monte Carlo simulation, and they call it a random walk. And it is a mathematical concept describing a path consisting of a series of random steps. It is a type of stochastic process, meaning that it involves some level of randomness or unpredictability. So this is your random walk. Just let me sort that out. The first thing we're going to do is we're going to have your number of rows, which we're going to have 20 rows that have information in them. So B1 is going to be your residual, and C1 is going to be your Y variable. So your residual is going to be the norm.inv.rand. That's a random number between 0 and 1. The mean is going to be 0, and the standard deviation is going to be 0.5. And you're going to copy and paste that formula down all the way down to B21. So it's going to create the inverse of the normal probability distribution PDF function. And then after that, we're going to establish our Y variable. So on your Y variable, on C1, it's going to be 1 plus B2. So that's what it is. And then on C2, it's going to be 1 plus B3 plus C2. And then you're going to copy that all the way down to C21. And then we're going to establish our lags. We're going to have 7 lags. And then we're going to use the autocorrelation function, which is the autocorrelation function that I used in the video that I made this morning. So you're going to use exactly the same formulas that we used this morning. And you'll notice that we've got 7 lags. So on lag number 1, you take 1 off the bottom for the first part of the formula, and then 1 off the top for the second part of the formula. And then you're going to divide that by the number of rows, which is going to be 20, and you're going to divide that by the variance of the number of rows, which is 20. Okay, so now on lag 2, you're going to take 2 off the bottom for the first part, and then 2 off the top for the second part. And you're going to repeat that until you get all the way to 7. So 3, you're going to take 3 off the bottom for the first part and 3 off the top for the second part. Number 4, you're going to take 4 off the bottom for the first part and 4 off the top for the second part. And number 5, you're going to take 5 off the bottom for the first part, 5 off the top for the second part. Lag number 6, you're going to take 6 off the bottom for the first part and 6 off the top for the second part. And 7, you're going to take 7 off the bottom for the first part and 7 off the top for the second part. But what I will do is I'm going to leave you a link to the video that I made this morning, and then you can watch that video as well, and that will go into the lags and the autocorrelation function. And then so what I did after I calculated my lags, what I did was I calculated y, which is your prediction, and you notice that y makes a linear chart. And let's see what we've got here. So y makes a linear, is a linear. Let me just see. And I'm going to see if I can do this. Trend line. And linear trend line. And we're going to put more options. So it's going to be a linear trend line. And it's going to be set intercept, display equation on chart, display R squared. So that's good. So you can see that this is almost a linear line because the trend line goes right through it. And then after we have made a chart of Y, which is a line graph, we're going to do a column chart, which is a parallelogram. And what that does is that shows you what the correlation coefficient is. And you can see that the correlation coefficient decreases with each lag. And so let's say hypothetically at some point the lags are going to start to be negative. So at the moment the lags, the autocorrelation coefficient is positive, but at some point it's going to be negative, which is what we had in the video that I made this morning about lags and autocorrelation coefficients. So I can show you that. So you can see here the one that I did this morning, and I will leave a link to the video for you. You can see at lag 6 you had a negative autocorrelation. So let's come over here. Let's move this down. And we'll just say lag 8. And then we'll say so this is your lag 8, so it's going to be C2, and then 21 minus 8 is going to be 13, but we'll see what we get there. $13. 21. And then we'll say and you'll see that in lag 8 it's now a negative correlation. So you can see here with lag 8 it's a negative correlation. So what we can do here is we'll delete this. And we'll say insert recommended. And you can see that lag 8 is actually a negative value. So if it's a positive value, then it means it's positive correlation. And if it's a negative value, it means it is a negative correlation. So you can see that lag 1 to lag 7 is a positive correlation, but lag 8 is a negative correlation. So what that's telling you is the more lags you have, the least positive correlation it has. And I just wanted to show you that as you increase the lags, then you are going to get a negative correlation. So I've covered everything that I wanted to cover. Covered the residuals, the Y, which is your prediction, your lags, your autocorrelation function. We plotted a graph of Y, and we plotted a graph of the autocorrelation function as well. So I've gone ahead and talked about everything that I wanted to talk about. So I'm going to conclude this video. I will leave the link to the previous video for you so you can watch that, so you can learn a little bit more about lags and autocorrelation coefficients as well. So thank you so much for watching my video. If you like my video, please like and subscribe, and I will be communicating with you very soon.